All right, so here we're going to come up with an equation that relates position and velocity, that eliminates time, our third variable. We'll start in a similar place that we did before, and that is that we know acceleration. So, well, let's write it out this way. So we will write the first kinematic, which is final velocity. It's acceleration times time plus the original velocity. And the other equation that we know, which is kind of a temporary equation, is where we related the two ways of looking at average velocity, and of course that was v plus VO divided by 2 equals x minus XO divided by time. Two ways of looking at average velocity. In this case, we want to eliminate time. So our goal here is to solve both of these equations for time and set them equal. It's the way I like to do it. There's other ways to do it. You can solve one of them for time and plug it into the other. I kind of like this way. So let's start with this equation right here. So the first thing I'm going to do, and I'll do this one in red, we'll say, is I'm going to solve this equation for time. So I have, first thing I will start with, I'm going to go V equals AT plus VO. I'm going to subtract this from both sides first. So that gives me V minus VO equals AT. And I'm going to divide by A to get T by itself, which leaves me with V minus VO over A equals T. So here I've solved this equation for time. Alright. In a different color, we'll use, hopefully this will work. I have some brown here, we'll try that. Down here, yeah, you probably can't see that too well, so we'll just do it in black. Down here, we're going to solve this equation for time. The first step is we'll cross multiply, and that's going to give us time times V plus VO equals 2 times x minus XO. And to get time by itself, all I have to do is divide both sides by V plus VO. So that'll cancel it here, and I'll have time equals 2 times x minus XO divided by V plus VO. Since time is equal to this from that first equation, and time is also equal to this, I can set these two equal to each other. So I can write V minus VO over acceleration is equal to 2 times x minus XO over V plus VO. Once again, I'm going to start by cross multiplying. Interesting, that means I have to take this entire quantity times this entire quantity, which is going to look like this. V plus VO, this thing, times V minus VO, equals A times 0, so it's going to be 2A x minus XO. Now, multiplying this. Normally that would require FOIL, and you could do it that way, first outsides, insides last, and so forth. But the truth is, you should recognize this. This is what's called a difference, right? If you have the same thing, but you have a difference here, you have what's called, it's going to end up as, I should say, what's known as a difference of two squares. When you multiply this out, you will get V squared minus VO squared. If you do FOIL, the outside and inside terms will actually cancel out. You'll have a negative V times VO and a positive V times VO, and they'll go away. So you just have the beginning and the end. Equals 2A x minus xo. So with the third kinematic, we actually end up solving for v squared. We write this. V squared equals, we add this to both sides, VO squared plus 2 times the acceleration times x minus xo, which is just your displacement, right? Your delta x. This is all you need for the third equation. The variables, just like we wanted, there's no time. The variables are your final position and your final velocity. Your initial conditions are your initial velocity, your acceleration, and your initial position. All those would be set at the beginning of the situation, but these would change as things went on. And so we now have three kinematic equations. We have V equals A times T plus VO. I will generally call that the first kinematic, and it relates time and final velocity. Second kinematic, did in the previous video, that's position equals 1/2 AT squared plus VO times T plus your original position. That, of course, relates time and position, final position. And then the third kinematic is the one we just came up with. V final squared equals V initial squared plus 2 times the acceleration times the displacement, x minus xo. And that relates x and V final. And so with these three, you can pretty much solve a bunch of different problems involving the position, time, or velocity of an object given certain initial conditions. Or if you know the later conditions, you might be able to find one of the original conditions, like acceleration or how fast it was going at the start, that sort of thing. There's a variety of questions we can ask. And in another video, I show you how to use these and how to set up a problem, what we call a kinematics problem, to make it as easy and as organized as possible.